Welcome to the dynamic learning hub of ExcelR at Andheri East. A prime spot conveniently located at just a 5-minute walk from LIC Andheri Metro. In our journey of over a decade, we have proudly trained over 2 lakh students. We have also been recognized by Deloitte, Silicon India, and other accreditation bodies. Experience learning like never before in our spacious and comfortable classrooms. With high-definition projectors and state-of-the-art acoustics in place, we ensure effective learning even to the farthest point in the room. The hybrid mode is a game changer as you can enjoy the benefits of a light classroom from the comfort of your home. Even if you happen to miss any classroom session, you can still attend the same session with the same trainer at the same time at your convenience, maintaining consistency in your learning progress. Wanna get started? Join us for a demo or career chat over a cup of coffee at our Andheri branch. ExcelR. We don't just train, we build careers.
Yes, so the collaboration with ExcelR was an excellent one. We conducted a Power BI workshop with Advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives.
The trainer, Mr. Karthik, was an excellent person where he explained in very detailed manner on how to give great insights using very complex data sets.
So it was a machine learning workshop. We learned a lot from the course, and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching, and it was fabulous.
This was a great experience for me. So I would absolutely love it if ExcelR and its team would come again to our campus and conduct more events like this.
It was a great course, and it started from basics and took me to a great extent.
The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with ExcelR was very smooth. They helped us in conducting the workshop smoothly, right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our Technical Fest Atmos, and I thank ExcelR for being a part of it.
I was very much interested in learning digital marketing course for a very long period of time, but I don't get a proper platform. So later for my college, I get to know about ExcelR and I enrolled in ExcelR course. It was really good experience. Our course has been taken by Mayur sir, and he was very good teacher. He not only focusing on theory part, he is doing how real digital marketing works, and it was in total very good experience. I get so much of knowledge here. They're not only focusing on study, they are also conducting different exam to test our knowledge, and as we are giving the exam, so to appreciate our work, they give certificates for the toppers, and along with the certificate they give hampers. Thank you, ExcelR.
Recently, I was searching for digital marketing courses online in Google, and I came across ExcelR, and I attended a digital marketing course which was for 15 days. My mentor Mayur helped me for attending these classes. So he is a very informative and helpful guy. In the course end, there is a exam which I topped. So I came to the ExcelR office in Bengaluru. This digital marketing course has helped my career and my skills to develop, and the certificate has helped my company to join. Thank you, ExcelR.
I came to know about this course from my college. Actually, for learning platform, this is very nice, and I learned from here ChatGPT and AI from online. Because he's teaching for me for AI generative and ChatGPT. We are using this technology in more. And after finishing the courses, I came from for collecting the certificate. I seen the classrooms and faculties. Classroom is very nice. After the completion of exam, they will give gift and certificates. Thank you, ExcelR, for giving these courses. I learned a lot of from this. I gained the more knowledge from here. And thank you for Excel for teaching us.
Hello guys, I'm Vikram Mahajan and I'm studying in Swami Vivekananda Institute of Technology College, and I came across a training program which was mobile app development using Flutter, which was given to us by ExcelR Solutions. I came across this program through my college faculty who told us about this program, that it is a very
take it forward now.
Yes, sir, we can start the session.
Okay, ma'am, thank you. So let's start today's session. And almost the machine learning, supervised machine learning and unsupervised machine learning we have already covered. And today, let me share first the screen. Yeah. So today we are going to cover that if you have already your machine learning model, you have built your machine learning model. So is there any chance to improve the accuracy, or if you are going to validate your accuracy, that whatever you are getting the accuracy? So we are going to talk about these things. One is that will be my model. We are going to validate my model, whether my model, whatever the accuracy we are getting. Okay. So that is basically good enough, or how you are going to validate whatever accuracy you are getting. So again, as earlier, I have uploaded here the day 14, that is for this session, the 14th day is, so model validation and hyperparameter tuning. Okay, so these two things we are going to cover today's session. And I have here the notebook and the data sets. These two data sets yesterday we have taken, and most of the time we are taking these type of the data sets, CSV files, and I will look into that how you are going to cover these things. So different techniques are there in model validation and hyperparameter tuning. So what does it mean by that you are going to work? And okay, let me just explain that what is basically what do you mean by the validation, and how you are going to validate your model. So okay, let me just open the OneNote that we already have written something here for the when we are learning was supervised and these things. So basically what up to this, what we have done, we have completed our supervised and unsupervised. So in supervised, we have seen regression and classification. And in unsupervised, we have covered clustering. That yesterday we have covered clustering. And classification, for the two sessions we have taken for the classification, supervised learning, and one session for the regression. Okay, so, and before that, introduction, machine learning, introductory, and how you are going to work on the these things. Introduction to machine learning we have done, and we have done EDA and feature engineering and different things, that pre-processing you are going, and feature engineering, different things we have done. And third session was for the regression, fourth session was the classification, and the fifth session was on the clustering. Now for this machine learning, in the machine learning part, we are going to have sixth session that we are going to validate our machine learning model. So we have already a regression model. Okay, so maybe that you have, let's say, linear regression. So linear regression model you have, and in the classification there we have taken different types of the classification, and that decision tree that we have taken, decision tree basically. Okay, so whatever the model you have, okay, so basically what does model do? So we are going to implement this model. Basically we are going to take the model, and we are going to pass some input to this model. So that input is not in our data set, the training data set. Basically it may be maybe for the like test, for the test we have some portion of the data set we have reserved for the test, but this model haven't seen this data, input data. So this model is going to predict our output. Okay, so what will be maybe prediction, what is, if your regression task is there, so prediction will be your continuous value, some continuous value, numeric value. And if your the classification is there, or some any classification type of the model you have, so that will be the prediction, will be your labels, or let's say that label in terms of the discrete value or the categorical value. Okay, so then let's say discrete value, maybe you are getting 0, 1, 2, something like that. Okay, for the labels. So for the class 1 you are getting 0, for the class 2 you are getting these things. Okay, so this way that we have completed, we have built model, and now we are going to check that whether this model is fine enough for the prediction for the unknown data. Unknown data here we are talking about data maybe from your data set, okay? But this is unknown. Why? Because that data set was not if those data were not used in the training. Okay, so these input data, now when we are going to predict, so we are going to take some data either from the data set that we already have. We have some reserved portion for the testing and validation. Okay, so what we are going to do, validation are the how you are going to validate this model. We have trained model, and now we are going to check that whether this is giving us like a proper accuracy or proper whatever the things are there. Okay, properly it is going to give us the result or not. Okay, so how we are going to validate that thing. So there are different techniques that we are going to validate. One thing is that what we can do, we can split our whole data. We can split our data set into two different subparts. One is training and other is test data. Training data set and other is test data set. And we are going to train my data, my model on this training data, and we are going to validate my this whatever the model we are getting, okay, on the test data. Okay, so at the time we can calculate, at the time of training we can find out, we can like we have different matrices, we have different like to measure the accuracies, and different matrices we have to find out how good my model is. Okay, so you can find out for the training data set also, and you can find out for the test data. So what we can do, if my model training accuracy and model matrices, okay, validation matrices, both on the data, this training data, and both for the test training and test data, my model performs similar. Okay, so we are going to say my model performance is fine. Okay, up to this, it may be like how much performance is that? Okay, is fine means we are going to say that training model, training accuracy, let's say that you got 90%, and while the testing for the test data you got the accuracy, let's say 88%. Okay, 88%. So we are getting near to this. Okay, but let's say that one scenario maybe happen like this, you are getting training accuracy like 90%. Okay, that's fine, and while you are going for the test data, the accuracy is only 70% or 60% or 75%. Okay, so in this way there are some problem with our training. Okay, so my model is not performing good. So whatever this type of the training, like while you are training your data, is your machine learning model is learning every data point, but when you are going for the test for the unknown data, that your model is not generalized. Okay, your model is not giving good accuracy. So what you can do here, this type of the situation may occur when you are going for the one way that it will be called as overfitting. Okay, in that, what is that? Model is basically while training model is learning good, but while testing, while it's going, model is going for the new data, unknown data, it's not performing well. Okay, so you can check, you can validate your model in this way, that you have splitted your data set into two, and you are going to check that whether model accuracy while training and model accuracy while validation test, whether both are nearly same or not. Okay, so one way that you can validate your model, that okay, my model performance is fine, my model is okay. Okay, so looks little bit more about this. So here we have taken what different types of the Okay, model validation techniques that you can go. So this is basically nothing. Model validation technique is nothing but what? Uh, you are going to check your algorithm. Your algorithm means that you are going to train your algorithm and you are going to get the model. Okay. Now your model or trained algorithm is going to perform, how it's going to perform on the unseen data. Okay. So that is you are going to check. So there are different techniques that you are going to work on this. So let's move to this. Okay, we have discussed that what will be overfitting and these things. And there are different techniques that we are going to cover for these things like train and test split. First, we are going to check, and k-fold cross validation will be, and leave one out cross validation. Okay, so validation is nothing but whatever you are, let's say that whole data set you are going to use for the training data. Okay, so you are not going to say that how I'm going to validate my model, whether model is good enough or not. Okay, you used whole data set for the training, and now you are going to predict it. So whatever the prediction is, that you are not going to say that how confidence I am with that output. Okay, with that like prediction. So what can we do? These are the different techniques that how much I'm confident about my model performance. So one way is using this thing. So most of the time what we are going to do when we are going to split into training subset and test. So we are going to take a larger part for the training and some smaller part of the for the testing. Okay. So there is like one by third for the test and 2/3 by for the test training. Okay, but it's not hard and fast. Like you may take 80% data for the training. You are going to train 80% on 80% of data, 20% for the testing. Okay, you can put like this. It's not hard and fast rule that 1/3 of that data you are going to put for the testing and 2/3 for the that thing. Okay, but it may be like 0.3%, means 30%. Here this is basically 30% for the testing and 70%, that's 70% for the training you can take like this. Okay, so it will depend on your use case and how you are going to, you can check like once like 20%, one 30%, and other time 33%. You can check with different values. Okay, but let's go for the like 20% and 80% or 30% and 80%. So in that case, as we discussed, that what we are going to do, we have basically what we have divided, and we have test data and training data set. Okay, now we are going to train our model for the whatever reserve we have taken for that training data. So we are going to train my model on the this training data, and later on we are going to do that thing. Okay, so it will be better if I'm going to one part. Let's say that I'm going for the training and test, and then we are going to implement this one. Okay, either let's go for these things, that whatever different techniques we are going to cover for the model validation, and then we have hyperparameter tuning. Okay, two things we have that we are going for the model accuracy, model whatever the performance matrices are there, we are going to validate those things. We are going to validate our model, and next is we are going to improve our performance. Okay, our model performance by hyperparameter tuning. So let's go for the next one, that is k-fold validation. Okay, we will have all these, like how we are going to split into train and test, and how you are going to check that how my model is working. Okay, whether my model is working in the training data. Okay, very good, accuracy is very good, and while I am going for the test set, it's not working good. Okay, so we can check all these things for the k-fold cross validation. So it's nothing but what we are going to do, basically let's look into this. Okay, so k fold is nothing but, let's say k is my 5. I'm going to say that 5 fold. So in that, what I'm going to do, whole data set, see here, whole data set I'm going to divide into 5 part. Okay, k is 5 here. So what can we do? Let's say that 1000 data points we have in our data set. So if I'm going to divide this 1000 data points into 5 subparts, so in each fold, so let's say this, in each fold, how much it will be here in data set, how much we have, 1000 data points. So in each fold, we have 200 data points. In each feed, like fold 1, fold 2, fold 3, we have 200 data points. Here also, here also, here also. Okay. Now what we are going to do, we are going to find out, in this way you can you can do that one. Okay, these, out of these things we are going to put, let's say, fourfold, these fourfold for the training and one fold for the validation and testing. Okay, so what can we do? So these green one, these folds will be used for training, and one fold that is in orange color you can find, it will be used for the testing. Okay, so in that, in the first method, that when we were going to split, okay, into the training and test, we also have done here, you can find out that 80% data is in training and 20% data is in test. Okay, and in the first method, we also have done this thing, like 80%, somehow 80% and 20% we have taken. Okay. So when you are going only one step, so you are performing, okay, train and test split. Okay. But in the k-fold validation or the cross validation, what we are going to do, we are not stopping here only. One step we have done, you can say one iteration, or in one go we have done this one. Now again we are going to, what we are going to take? We are going to take second fold, that is this fold for the testing and rest of the four fold for the training. Okay. So again in my training, for 80% of the data in my training. Okay. And in 20% and in test 20% data. Okay. So what will be there? Like this data is used for the testing here in the first phase, and in the second phase, this second fold is used for the testing. And in the third fold, you got like third fold. Okay, in the fourth phase, like fourth phase is nothing but once you done all these things, once you done the training on these four folds and you tested. Okay, so you will get some training accuracy. So you got the training accuracy in this. Okay, and training and test both accuracies. Okay, test accuracy and training accuracy. You have that training accuracy and test accuracy, no, one. Okay, here you have training accuracy and test accuracy, training accuracy 2 and training test accuracy 2. Here you will have training accuracy 3 and training accuracy like test accuracy 3. Okay, here you will have training accuracy 4 and test accuracy. So you will have like 5 training accuracies and 5 test accuracies corresponding to each other. Let's say here, let's what we are going to say for this test accuracy 1. Okay, we are not going to test. Let's move. Okay, let's move. Very easy. So these folds. So you will get on average. So how you'll get here one training accuracy, here you will get training accuracy, here you will get training accuracy, here. So 5 different training accuracies you will get, and here you will get 5 test accuracies and corresponding to each other. Okay, so in this way, whole data set one by one went into the testing, and whole data set one by one went for the training. Okay, training and testing. So in this way, in each 5, in whole 5 like steps are in the group. Okay, in whole circle, you used for whole data in the training also and whole data for the testing also. Now you can find out that whether my accuracy is good or not. Here you can find out like at the training time, maybe like you are getting 90% accuracy, and for the test time you are getting 85% accuracy. Here you are getting 95% training accuracy, and here you are getting 90% test accuracy. Here you are getting, let's say, 93% of training accuracy, and here you are getting only 80% of test accuracy. Okay, so this type of the different training and test accuracies you will get. And now you can say that basically what you are going to say, now you are going to make like average or something like that to check that what will be your accuracy. Okay, so you can check, you can do a lot of things here. Okay, so let's move to the proper okay, let me delete this so that you should clearly. Okay, so what it's doing basically, you can go here and check that. Sorry for this. Okay. Huh. So this cross validation is nothing but, what is that? Is an approach to use how you are going to estimate the performance of the machine learning model. Okay, and we have different thing like how you are going to estimate some statistical term, and there is variance. Okay, so when you are going for the machine learning or the data science model and the project, so already you have to know about little bit statistics. Okay, what does it mean by estimation, what does it mean by variance? So many times we are talking about the variance and these things, and we are talking about, we are going to estimate our machine learning models parameters. Okay, we are not going to directly calculate the values of the parameter, but we are going to estimate. Okay, so there are different terms that you can use. Okay, so when we are going in the statistical way, like some estimation is there or some variance is there, something like these things. Okay, so little bit knowledge of the statistic is required for the better understanding. So let's say that what it do basically, that we already have covered. You are going to divide your data set into k parts, and k may be whatever, like 5 part, 10 parts, and something like 8-fold, something like that you are going to. But most of the time, let's say whatever the split you made, now you are going to take only one split, and you are going to one split for the testing and other split, like we are going for the 10 split, so you will hold one split for that thing test, and other 9 split, 9 folds you are going to put into training. Okay, so in this way, what can you do? If you are going for the 10 fold, then what will be, your 90% data will go for the training. Okay, and 10% data will go for the testing in each phase. Okay, in each phase, rest of the things will be same that we already have discussed. Okay, so again, you are going to, in the next phase, you are going to take the next the second fold for the testing, and rest 9 folds for the training. In this way you can go. Okay, so whatever the training, like whatever the split you are going to take, one split for the test, and rest of them like k minus 1 or something like that, so those will be for the training. Okay, so you are going to perform this type. If you are taking like say five folds, you are going to perform this thing 5 times. Okay, and you are going to summarize, you are going to take mean and other things for your performance. Okay, so in this way, whatever the result you are going to take, let's say that in one fold you are saying that I got 95% one in one fold. Okay, training accuracy. and let's say 90% testing accuracy you got. Okay, but maybe in the other fold you are getting only 80% training accuracy and 90 and 85% test accuracy, like this. Okay, so whatever you are going to do, you are going to take the mean or these things. Okay, so you can say that okay, my performance, my model performance is not so high like 95%. My model performance is okay, about near about to like 85% or something like that. Okay, so you are not relying only one fold, but what you are going to do, you are going repeatedly, you are doing your training repeatedly, and you are going to measure repeatedly for the k times. Okay, so it will be that. Okay, so this is that we have done. And other is like one leave one out cross validation. So in that, what we are going to do, in that there is, it's very simple, it's very simple. Leave one in. What this method is doing, basically leave one out, it's doing like say 1000 data points you have, 1000 data points we have. So in that, whatever, leave one. Okay, so you have to leave one and rest. So you are going to take one for the test and rest 999 for the training. Okay, just how you are splitting. Okay, like this. Okay, so this is basically a version of the k-fold. Okay, k-fold cross validation. How? If your data set has, let's say, n is the total data points in our data set. This is n. Okay, so you are going to say that n fold. Okay, so it will be n-fold cross validation. Simple. Like you are going to divide your data set into n-fold. Okay, here you have 10, 100 or 1000 data points. So you are going to say that 1000 fold. Okay, cross validation. Is it fine or not? So you are going to divide your whole data set, 1000 data points into k fold, fold 1, fold 2, and like this you are going to have fold 1000. Okay, this way. So each fold will have one data point. Okay, this also have one data point. So see how, like each fold having only single data points. Okay, so you are going to put at first time this one fold for the test. Okay, and rest for the training. Okay, so how much you will get out of 1000 data points, only one data point for the training, sorry, testing, and rest 9999 data points for the training and one data point for the testing. Okay, so out of this, what will be the percentage? If you are going to say what will be the percentage, like 0.001%. Is it fine or not? And here you will get 99. So this will be the percentage here. If you have your like 1000 data points, rest way you can, let's say, 2000 data points, 1 million data points you have. Okay, so out of 1 million data points, 1 million data points, you are going to take only one for the test at first time and rest whatever the value will be for the training. Okay, so this way, this leave one out cross validation will work. Okay. So if the cross validation confuses that size of the fold is 1, k is the number of the observations. Okay, so each fold will have what? 1. Each fold will have one unit. Okay, because we have divided whole data set into n observations. Okay, we have n observation, n data points, so we have divided into n folds. So this is basically variation or type of the cross validation that is we have discussed. Okay. So there are measures of the model accuracies. Okay. So we are going to work that what are the measures for the model accuracies for the regression techniques. And also we have gone through these things. Okay. We have gone through these like mean square error, mean this, and one most important thing that I wanted to discuss is basically okay, the different things are there: mean square error and mean percentage error, mean absolute error, and mean. So this is nothing but what? This is the actual value and this is the predicted value. Actual value and predicted value, and you are going to for the each data point you are going to take and you are subtracting, then you are squaring, and some you are making sum, and so mean square error. So this part actual and minus predicted. Okay, so this is your error. Square error you are going to square, and mean you are going to add all these values and you are going to take mean. Okay, so we can calculate mean absolute value. Here you are not going to square, you are going to just take the absolute. Means if value is coming negative, you are going to make it absolute and you are going to take mean. Okay, so different techniques. Mean percentage error, here percentage error. So you are going to take error, you are going to divide by the actual value, then we are going to take percentage. Okay, so this will be case mean absolute percentage value you are going to take like this. Okay, so instead of the actual difference, we are going to take what? Absolute difference. So there are different techniques that we will look into this thing. It will be good to understand. Okay, and okay, for the classification we are going to test all these things. Okay, in when we are going to implement accuracies. So sometime like yesterday or day before yesterday we have discussed when we were discussing about classification techniques. So we discussed that what will be the accuracy. Some student asked that actually how accuracy works. So we discussed that one also. But what is that? Number of the correct prediction divided by total prediction. So let's say that the our model has predicted, we have 100 data points and our model predicted how much correct. Okay, so let's say 88 prediction is correct. Okay, so this will be your 88%. Okay, so out of total prediction, how much accurate, how many accurate predictions is done by your model. Okay, so that is basically our correct prediction and that is our accuracy. So one thing here we have the confusion matrix, and most of the time students get confused. So these two things, true positive and true negatives. Okay, true positive and true negative, I want to give you with an example. Okay, so don't go here this up to now. So let's say this is basically a disease we are going to talk about. Okay, let's say diabetic. Okay, diabetic is means that person is having this disease. Okay, diabetes. Okay, here I am going to say not diabetes. Okay, not diabetic. Here diabetic, and here not diabetic. Okay, so you will get a little bit understanding. So these are the actual thing. This is the predicted one. Okay, so this from here the rows you are going to talk about this predicted values. Okay, and here this is actual. So let's say that the thing that is predicted is diabetic and actually that is diabetic. Okay, so you are going to say that okay, correctly predicted. Okay, like here you have seen this lady is really pregnant. Okay, and our model is also predicting that this lady is pregnant. Okay, so true positive means your prediction is true. Okay, and positive is means anything that is positive, like pregnancy is positive or the diabetic person is positive. Okay, so that is you predicted true class means pregnancy, or here the diabetic, that will be this thing. Okay, other thing is that your model is predicting not diabetic and that person is actually not diabetic. Okay, so this is also correct. Okay, this is correct prediction, and this is also correct prediction. Okay, that your model is predicting that a particular person is not diabetic and actually that person was not diabetic. So that is correct prediction. Okay, here that it says that this man is not pregnant. Okay, so obviously that man is not predicted. Man will not be pregnant. Okay, so this is truly predicted but negative. Okay, so this will be negative. Why? Because that particular thing is in negative way. Okay, in negative means the opposite of that. This is not diabetic, not pregnant, not this type of things you can take. Okay, now there may be two different types of the error your model is going to do, and those models you have to perform, you have to take into account. That is the most important thing to understand. Most of the students, most of the time, students are not getting this thing. This is positive means diabetic. Okay, so model is saying that actually the patient is diabetic, but the patient was not diabetic. Okay, so falsely, so it will be incorrect. So while predicting, model said that the person is diabetic, but what is said that actually the person was not diabetic. So it is incorrect prediction, but it is incorrect positive prediction. Okay, like any disease, positively you are predicting that the disease is positive. Okay, here you can find out the pregnancy is positive. So, but it is not that. Okay, so it is not that. So anything is that the person doesn't have the diabetes. Okay, but your model is predicting the person has diabetes. Okay, so this type of error you are going to say that false positive error. Okay, this will be false positive. Falsely, incorrectly you are predicting it as a positive. So this is incorrect. And negative, actually that person was diabetic, but your model was predicting that not diabetic. So falsely you are predicting negative. Okay, because here the woman is pregnant, but it says that your test is negative. Okay, so if this is the case, then this will be the false negative. Okay, so this will also be incorrect. Okay, so these two things will come here, like in the correct prediction, like actually it was the diabetic and model is predicting diabetic, and here also actually it was not diabetic and model is predicting not diabetic. So correctly predicting. Okay, so these two will come into the correct prediction, and rest of the type, opposite type, will go into the that one. Basically either false positive or false negative it will be. So hope this is little bit clear. So using these things you can find out, using these things, true positive, false positive, and these things, precision and recall. So you can find out precision, you can find out recall, and that is FS score. Okay, so most of the time you are going to work with accuracy and you are going to work with this measures. Okay, F score or F measure. Okay, so this is very important. You don't rely only on the accuracy, you go for the F scores also, and recall also, and precision also. Okay, so if you are going for the F scores, it will take into account recall and precision. So you have to focus mainly on accuracy and F score. Okay, so you need both good accuracies, like F score should also be good. Sometime you may get, sometime you may get like this. Okay, your model is predicting accuracy something like 90%. Okay, but your F score is what? F value is only let's say you are getting accuracy 99, means we are going to not 99, let's say it's 95, so 0.95. Okay, and if you score you can get like 0.04 or 0.5. Okay, only 4% is there. Okay, so you have to look into account, these are very important. Or let's say it's only 44% or only 30% or is 0.3. Okay, like this 30. So when you are going to find out accuracy, let's say 80%, and you are going to find out your F score something like 78%, 78, something like that. Okay, both should be like near to each other. So that model will be your good model. Okay, one model is saying the accuracy is very high, but F score is very low. So that is there is a case of the false positive and false negative. Okay, so you have to avoid the false positive and false negative. Okay, so let's go to the we have done this all the thing that validation. For the validation we are going to work on. So let's move to our Jupyter notebook, and before that, okay, I'm sharing the project link. Okay, all these things where it is, so you can go for this. Okay, and go for today's last day, like not last, today will tomorrow will be the last 14th day. That is model validation and hyperparameter tuning. Okay, so almost 50% for the model validation we have covered. Then we are moving to the hyperparameter tuning. Okay, so I am sharing this one to everyone. You can go and you download these files. Okay, you download these files, that is IPYNB file and CSV file. Okay, newspaper data, this data set, and PIMA India's diabetes data. You already have downloaded. Okay, if not, because in many times we have used these data. Okay, so when we were working about supervised learning for the classification, so we worked on these two. Okay, so go for this. So you can find out what different things we have taken here. Like we are going to work on validation technique. So we are going to implement train and test one first, then cross validation. Then we are going to work on the one, leave one out. Okay, and different measuring accuracies you can find. Okay, for the this regression, for the classification, and then we will move to the hyperparameter. Okay, hyperparameter is very important to understand and to tune. Okay, so let's move to the our collab. Okay, so go for the collab. We are using collab. Okay, you can use you have if all the Python libraries, NumPy, Pandas, SciPy, and this scikit-learn you have installed. So okay, that's good. You are going to use your local Jupyter notebook. Okay, yeah, for the sake of simplicity, some students say that they have not installed all the libraries and all other things. So we are going for the Colab. Okay, so that's good. You can use Colab. So this model validation methods are there. You are going to use, and within that, we will get all the things. Okay, all the things whatever we have discussed up to this, like three different types of the validation techniques and the accuracies for the regression and classification. So for this, we need basically to upload our data set, where we are going to upload this PIMA India and this thing, and I think another data set we need. Okay, so let's upload both data set. Okay, so what we are going to do, it will connect here. Let it connect, and here we are going to have the folder. Okay, so here you are going to upload model validation. Make sure that you have uploaded for the model validation. Okay, so we have two data set, this and this. So select both data set and you just upload. Okay, now our data is uploaded. If you are working locally, so and your CSV file and your Jupyter notebook file are in like same location at in same folder at same place. Okay, so just you can give this name only. Either if in different location, you have to put the proper location. Okay, so here you can find out where is my PIMA India diabetes. This one you are going to take, copy the path, and you are going to put here like this. Okay, so this content sample and all these things you will get. Already many times we have done these things, and basically this thing that which technique we are going to take, logistic regression. Okay, so this logistic regression is basically for the classification. Okay, Name is regression, but the work is for the classification. Okay. So we have done k nearest neighbor and that one decision tree. Okay, you can use logistic regression also for the classification technique, for the classification algorithm. So what we have done, you already done these things. Okay, so you can go like pandas like this. From pandas you are going to import a read csv function, the method, and directly you can go give the function name here, and the file name you are going to put whatever csv file is there, and you are going to give the column names. Okay, so if your data don't have the columns, you can give the column names like this. Okay, but maybe when you are downloading this one from kaggle or from the any other resources, not source, you may get that what different columns are there, maybe already column names are given. Okay, so you need not to put these things. Okay, pregnancy and skin taste, mass, press, different ages, their class and prediction. Okay, all these things you get. Okay, so if your data set already have these things, so you need not to do. Okay, so now just I'm going to talk about what we are going to talk. Already we have done these things. Okay, for the training we have taken this, for the for the training data we have this. Okay, and this will be your input features. You are going to take input features, you are going to take the label, and you are going to take size. Is what size? Test size means you are going to take 0.33, means one third you are going to take for the test, and rest, that is what this will be using. We are going to use this thing as train and test split, that first method that we have discussed. Okay, so one third means 1 over 3, that is be 33.33%. Okay, but we are going to take 0.33, means 33% for the test, and it's 67% for the. Okay, so this is train test split. This method will divide your both. Okay, for the input feature also and for the output labels. Okay, for your class, that is your output are the labels of the target values, and these are the input features. Okay, so it will divide input features also into 67 and 33. Okay, so 67% of the input data set for the training. Okay, will go to the training, and 33 will go for the these things. So this way you will get four different parts. Okay, this X train is nothing but training data, that is 67%. Let me write here somewhere 67. This will be, let's say 33 we have taken. Okay, so this train where train you are getting. Okay, so this X train is nothing but what? Input features. Okay, input features, whatever input features are there, and these will be how much? 67% for this thing. And X test you are taking. Okay, X test, so these are the for the, you can see this will be for the training. This is X you are taking, this is basically feature, input features. Okay, let me show you with proper this one. Okay, let me first write 67%, but it is used for the training. Oh, sorry, test. This will be used for the test. So these will be the input features. What input will be? So let me show here. Okay, so from here to here, you will find from here to here, from starting to the all data from starting to the end, these will be your X, that is input features. Okay, so out of X you are going to take 67% for the training and 67% or 33% for the test. So that 67% will be called your X train. Okay, and rest 33% will be called your X test. Okay, hope this is clear. And okay, so what, where we are here? Okay, we are here. and we can find out what, and we can find out same way for the y also. Y will be what? Y will be your this one. Okay, so better to write here. Okay, so better to go. This will be your y. Okay, so this is y, and this is your whole up to here, like 8 features. 1 2 3 4 5 6 7 8 features are x, and out of x features we are going to take 67% for the training, and that's 33%. Okay, so this will be y. That will be only these, like 0 1 0 1, that is either diabetic, not diabetic, diabetic, not diabetic. So train and y test you will get. Okay, so these will be your target, or the labels. Okay, target variable. Okay, and you will get for the train, that will be, sorry here, x test. So I made a mistake here, it will be only 33%. Okay, so this is for the test now, so that will be 33%, and here that is train, that will be your 67%. Only target feature, this one, out of this you are going to take 67% for the 67% of this y for the training, and this is target. Okay, 33% for the test. So hope this is clear what this x train and y train and all these things are. Okay, sometimes it make confusion for the students. So let's move to the proper coding one. Okay, so you'll get train test split from where? From the sklearn model selection. This module you are going to take train test split, and it will split on the basis of size, whatever the size you have given. So size you have given how much? 0.33. Okay, so now you are going to find out, we have taken, we have the model, and we are going for the 300 iterations, max iteration, and we are going to fit for the train. See here, we have taken only train, only 67% of data we have taken here. And now we are going to find out what is the accuracy. Okay, what is the model accuracy is? Model accuracy is about 78%. Okay, so we got this one, model accuracy. Okay, so this model accuracy is based on the test, and here we have trained on the training data. Okay, so this you can find it, check here, like x train, and we trained the model on the x train, means only 67% data we have trained. And when we are going to like result, we are going to like validate the model, we are going to test the model, that is on the test data, that is unseen data. Okay, so on the unseen data it is basically 78%. Okay, so you can use cross validation like k-fold or something like that. So all the things you are going to do, same thing, you are going to take x and you are going to take y. Now you are going to put here how many folds you will have. So you are going to put here how many folds? 10 folds. Okay, and you are going to take this k-fold from the model selection. You are going to take k-fold, and this k-fold basically will do what? It will divide your whole data into whatever the number of the folds you have taken. So here we have taken 10 folds, it will divide your data into 10 folds. Okay, and shuffle is true, means you are going to shuffle again after taking each fold. Okay, you are going to shuffle the data, and again you are going to meet regression. Okay, logistic regression, and you are going to validate your model. You are going to validate your model by cross validation score. So this cross validation score is basically when you are going to put cross validation score, it will call the model, it will train the model, and then it will, how it will train? It will take the data set, that is input features and output feature whole, all the input features and all the output features it will take, and it will depend on how much it is going for the training and how much it is going for the test. Okay, it will depend on this CV, that is parameter. Okay, so it will depend on the fold, how much fold you are getting like this. Okay, so this k fold will hold your splitted data. Okay, how you are going to split your data? So this will take, let's say you have taken 10, So 10%, 10% it will reserve for the training, testing, and rest 90% it will do for the training. Okay, so it will go for the 10 times. This model will be trained 10 times on the different folds. Okay, and after that it will get accuracies, 10 accuracies it will get. Okay, now it is going to find out the mean or the average of those accuracies. Okay, so finally it will give you. So this function will do a lot of things. Okay, cross validation score, basically it will take model, whatever the model you have defined, it will train the model on these data according to how much folds you have decided. Okay, so you have decided like 10 fold, 10% for the test and rest 90%. So it will do 10 times. Okay, for each fold, first fold at the first time it will hold. Okay, for the test. Then in the second training it will take the second fold for the test, and different way it will go, we have discussed. Okay, so now it will give you the result, accurate result. Okay, here we have taken that only one time we have splitted data and we trained on the different fold, different data, subset of data, and test on the different. So here you can find like this. Now you can say, obviously when you are going for the cross validation with k-fold cross validation or something like that. So it will take here 10 folds are there, so 10 accuracies it will get. Okay, so in some accuracies, let's say one accuracy is 90%. Okay, another accuracy is 85%, another accuracy is 80%. Okay, maybe some accuracies you are getting 81%, less than 80%. Okay, so finally you are going to get the final result, that will be your average accuracies or mean accuracy. Okay, so you are going to find out what the mean of this. Okay, and one thing, let me show you that you can find out what are the results here. Okay, so you can get. Okay, so 10 times for the each fold, it will give you the test accuracy. Okay, basically, so at the first time it got how much? 83%. Here it was like 78. Okay, so for the first fold, when 10% of data was reserved for the testing, okay, it was accuracy was 83%. In the second fold it was only 74. In the third also it was 74. Here only 80%. Okay, that is good. 80%. Here 79%. Here 77%. Here see, here in one fold, you got only 66% accuracy. Okay, 80, 82, 73. So you are going to find out what will be the mean of these accuracies. Okay, you are not going to say that my model is 83% accurate. Either also you are not going to say my model is only 66% accurate. Okay, so what you can say, you can take mean and you can say that my regression model is basically how much accurate. On average my regression model is 77% accurate. Okay, and you can find out the standard deviation. So this model varies, how much the accuracy varies for this model, this standard deviation will say. Okay, so standard deviation, you have, if you have studied in statistics, so this will give you the some value, some insight that the data, how the data points are away from the mean. Okay, how much data, any data is deviating from the mean. Okay, so that is the case. All the data points you are subtracting from the mean and you are going to find out this one. Okay, so this will work something like that, 77 let's say, and this 83. So yeah, we are not going to, so this how much this data point, this this basically accuracy is deviating from the mean data. Okay, 77 and 3 6. Okay, let's say 6, almost around 6. So 6%, 6 point accuracy, it's deviating from the mean. Okay, this is deviating 3, this is deviating almost 3, this is deviating 3. Okay, so this way you can find out. Okay, so your this one your standard deviation will give you. If you are getting too much standard deviation, let's say 110 or something like that, it will not go to 100, but if you are getting your standard deviation like 10, 20, okay, and in other case you are getting your standard deviation 4, 5, 2, 1, okay, like this. So you will be, you are going to find out this way, like tenfold, and you are going to find out the standard deviation. So when your standard deviation of accuracy is lesser, that is the good thing. Okay. That means most of the accuracies are closer to the mean accuracy. Okay. So that is the best. That will be the best. Evaluating using model one lever. Okay. So what you are going to do, you are going here, one lever, same thing will be there, and it will just take one lever. Okay. So again, cross validation accuracy, cross validation score. This function will call here. You can find the model. It will take model, it will take whole data, input features and output, and it will look this one. Okay, so leave one out. This function will do what? Like k fold function did what? It will divide it into 10 folds. Earlier that we have taken number of the folds is 10. So what it will do, how many data points we have. So here you can find how many data points we have. 768 data points we have, okay, in my data set. So it will divide all the whole data set into 768 folds, and only one fold it will take. Okay, so can anyone guess like how many accuracies you will get in this? Okay, how many accuracies you will get in this case? Just 1 to 3 minutes I will wait if you are listening. So how many accuracies you will get? Okay. In the previous one, we were dividing our data into 10 folds. So we got 10 accuracies here. And here, how many folds I'm going to divide? We are going to take each fold one data point, and here I have how many. Just you can check that how many, six something. It was around. You can go and just hover over this. So 6768. Okay. So this data set contains 768 data points. So it will divide into these many folds. Okay, 768 folds, and each fold will contain one data point. Okay, only one data point. So for this type of the data, you will get how many accuracies? You will get 768. As many data points, as many samples in your data you have, as many accuracies you will get. Okay, now you are going to find out the mean accuracy or and the standard deviation on the basis of this. Okay. So what you will do? Just run this. Okay, and you will get results. And again, that okay, it will take time. How? Because for each how many accuracies it has, how many data points is it? 768 data points, and it will go for the 768 times. It will train the model. Okay, and each training you have maximum 30 iterations. Okay, so you can find how many times it will go. It's going for the 768 times it will train. Okay, and each training it will go for the 300. Okay, 300 iterations. So how many iterations it will go? Okay, so you can check how many. More than that, 1 lakh, more than 7 lakhs. Okay, millions time it will iterate. Okay, so for this thing, so you can go and you can check for the results, that how many results you will get here. Okay, so see there, you will get almost how many how many you'll get. Okay, you can check that what will be shape you can use or not. So 76, 768 you will get, and actual values you can find out this with the result. Okay, so how can you check that what will be the accuracy and what will be not the accuracy? Okay, so you have only one data point in our test. Okay, you have one data point. Okay, while testing you have one data point only. Okay, so either this prediction will be true or false. Either it is correctly predicted that this data point belongs to which class. Okay, so if this is correctly predicted, so it will be 1 over 1. Okay, if not correctly predicted, so it will be 0 over 1. Okay, so either you will get 1 accuracy, means 100% accurate. Okay, for the first fold it is 100% accurate, and either you will get 0% accuracy, means for only single data point you are going to predict whether it is belonging to correct class or not. Okay, so you will get either 0% accuracy or 100% accuracy, because you have in your test data you have only one data point. So here you say these, and for this fold 1 2 3 4 5 6 7, for the seventh fold the accuracy is 0, because only one data point was there and that data point was incorrectly predicted. Okay, so you got that 0. Okay, now you have to find out all accuracies, either 0 or 1, and you have to find out what will be the average and what will be the mean. Okay, so let's go. So average means you are going to add all 768 accuracies, 1 1 1 1 0 0 plus 1 plus 0 plus 1 plus 1, something like that, and you are going to divide by 768. Okay, so now you are going to divide, and now again you get that 77.6. So almost 77 accuracies, 77% you are getting here like once. Okay, and rest 33% zeros are there. Okay, so standard deviation you can go, and if you are going to compare, here standard deviation was 4.96. Here standard deviation is 41 point, and here what was standard deviation was 4.9, and here standard deviation is 41.6. Okay, so this way this standard deviation and shows that our data point, what is the like what will be the mean is like here you are going to find out, if you are not going to multiply with hundreds, you will get 0.77. Okay, so some data is very away, like 0.77 you will get the mean. Okay, and your data point is either 0 or 1. Okay, so this is somehow, let's say 1 is near to that mean, but 0 is very far away from the mean. Okay, so you will get the standard deviation greater. Okay, so this way you can go, you can check. Okay, if your standard deviation is high, this means you have to avoid that type of the accuracies. Different accuracies model other than the percentage. Okay, you can find out what will be these things. So we are going to work on the newspaper data, and we are going to work for the which linear regression. Okay, so for the regression you can go for the this linear regression we have already studied, and we have done all these things. Okay, so and also this R square we have done. Okay, also we have done R square, that you are going to get 91.8%. Okay, 91.8% linear regression you are going to find out the accuracy. Meanwhile, if you have any doubt, anyone has any doubt in theory or in the practical, so we can discuss. Okay, same thing that you are going to here we have taken linear regression and the model, and any model for the linear regression or the regression things, you are going to take what? Model dot score. So it will give you R square, and we have discussed R square is what? How many, how it is going to find out in the X means that input feature, how input feature is going to describe your output. Okay, so how much input feature is efficient to describe, or you're going to get all the properties of the your output. Okay, so that it will be like 91% input feature is efficient enough to describe the variation in your y. Okay, so variation here means if x is varying, so how much y is going to vary. Okay, so 91%. So the mean absolute error you can find mean squared error. Okay, so all these things you can check. All these things you can check. And with a different model, not only for the linear regression, you go for the different regression models. Okay, lasso regression you have ridge regressions, you have different regressions. Okay, and whatever we have done about like random forest and other things, they can also be used for the machine learning classification and regression. So let's say that you have taken 10 machine learning model for the regression. Okay, so now you find out all the matrices for all 10 regression models. Okay, and you can compare that which one is going to be better. R square you can find out like this. Okay, we have taken here this regression. Okay, that is also good. You have taken this regression, you are going to fit this, you are going to find out the score. Okay, so very simple, just you import from the linear model, this regression is there, and you are going to take that how much the value is 91.8. So almost similar, 91.8%, here also 99. That's fine. So simple linear regression or the ridge regression, both are given the accuracy same. So now let's move to the model classification that we already have done. All these things we have done. Okay, just you are going to all these things, train test. Just here we have taken what? Different random forest. Okay, you can take random forest classifier. Earlier we have done with what? With the decision tree. Okay, so you can check with different models. Okay, random forest classifier now we are going to take. Earlier we have done decision tree. Okay, so you can go for the accuracies, different accuracies. You can do all the things. These X, how you're taken X, how you're taken Y, how you are going to take X train, Y train, and all these things. Okay, now this from the ensemble method, random forest classifier you can import. Okay, and you can give random states. What will be different parameters are there? You can check with the scikit-learn official library. Okay, so what is accuracy, what is confusion matrix, what is classification reports? So this classification report will give you all the things like precision, recall, FN score, and all these things. Okay, so go for the accuracy. This is whatever, this is the where it the support and the things. What is that? Accuracy. Okay, so how much accuracy you are getting? Classification report. Okay, confusion matrix, these out of the data set, like we have in this PIMA India, that how many data points we have in PIMA India. So let me check how many data points we have. Okay, so okay, this will not go like this. We can go with this PIMA India. Okay, and check how many data points, but still we have to go into our how many in training. Okay, so how can I check training? For the training, just over here. Okay, test. Okay, this hover over here and you'll get a little bit about this. Okay, 231. Okay, so out of 231, this is correctly predicted as it was. Okay, it was diabetic, so it predicted diabetic like 128, and 48 it predicted how much? 48 is predicted not diabetic, and also it correctly predicted not diabetic. Here you will get like incorrectly predicted not diabetic, and here incorrectly predicted diabetic. So these things you can find with the this confusion matrix and these 18 and 37, these are basically your false positive and false negative. Okay, so you have to avoid these things. If your model is good enough that these values like 18 and 37, these things are very less, that model is good. Okay, so your model is going to give us how much the FS score, that is 82 here, and basically this will be for this class 0 means not diabetic and class 1 means diabetic. Okay, so for diabetic class, how much F score is 64, and for not diabetic class, how much score is 82. Like this way you can find out precision and support, different things are there. So on average your this one accuracy is 76. Okay, and how much it's going to put the correct, that is 231 out of what, that you have to check that. Okay, this will be the support values. Okay, so okay, test we have done here. Okay, yeah, 231 out of 231, how many percent accuracies is there? So you can find out 128 plus 488, so 16. So you will get almost how much? 146. Okay. Okay, leave these things. No, we are not going into too much detail here. We don't have too much time here, but you have to focus on the FS score most of the time, and you are going to focus on the accuracy. Okay, so okay, when accuracy is okay, this one is accuracy, and separate way we have printed here accuracy. So focus on this one accuracy, that is your 76% accuracy, and your F score is this. You can make it average. Okay, for both classes, so it will go around 70 something. Okay, 70. So almost your accuracy and F score you are getting closer. So your model is good. Okay, your model is good and reliable enough. Okay, if you are getting higher accuracy and higher F score both, your model is good also, and your model is reliable also. Okay, if you are getting accuracy like 99% and F score is very less, like 50, like 0.5 or zero point 0.6. Okay, so your model is accuracy is good, but your model is not reliable. You can't use that model. It will give you many false negative values. Okay, so that will be the case. Hyperparameter tuning. Okay, some okay attendance you will get. Okay, attendance you will get. Ma'am will share the attendance. Don't worry, you will get the attendance. Hyperparameter tuning. Let's move to the hyperparameter tuning. Let's try to understand little bit. Okay, so we are going to work for what? K-neighbors classifier. Okay, so let me show you that what will be the KNN scalar. Just go K-neighbors classifier. Okay, so in linear regression, let's talk about the linear regression. Okay, in linear regression, we were trying to find out the like beta naught and beta 1, that is intercept and the slope or the gradient. Okay, so these values were estimated or calculated, but if you give more statistically, the actual word is like estimated. These parameter values are estimated while training. Okay, so you found the optimal value of the parameter. Okay, so whatever the unknown quantity you are trying to estimate, you are trying to find during the training, that those values will be your the parameters only. Okay, but here in the case of the some values that you are going to pass, okay, to the model, here you will see some values you are going to pass the model. Let me show you here. This KNN, and this will be your K nearest neighbor. Where is this? Let me check that. Okay, where grid we have defined. Okay. Here we defined how many parameters are there, how many this one, the neighbors for this. So in between 1 and 50, I'm going to make 1, 2, 3, 4, 5, 6 up to 49. So first time I'm going to take number of the neighbors 1, second time number of neighbors 2, 3, 4, 5, 6. Okay. So I'm going to check for all neighbors for which neighbor the model is working good. Okay. So that will be the main thing. Attendance you will get, don't worry, you will get the attendance. Okay. So just complete, just 20 minutes are there, just 20 or 15 minutes we are going to complete. This is very important, just learn. Okay, you will understand that what is hyperparameter and what is parameter, how you are going to fine tune. This is very important, and to learn about and to go when you are going into the interviews and other things, these are the questions you will get. Okay. So here we are going to decide my parameter. Okay, whether this parameter is passed by me, passed by the machine learning engineer who is training the model. Okay, passed by human. So this will be this type of the parameters will be called as hyperparameters, and hyperparameters you are going to choose. So how I'm going to choose? I'm going to find out a range of the hyperparameters, and I will train the model for each hyperparameter. Let's say I'm going to train here the k nearest neighbor at the first, taking k is equal to 1, and I will find the accuracy and other things. Next time I am going to train the model for the k is equal to 2. Next time I am going to train the model for the k value is 3. So these values I am passing. Okay. The the trainer is passing. Okay. Who is training the model? He or she is passing these values. Okay. And not only one value, in each model training I'm going to pass different. So okay. So I thought that okay, I checked that okay, let's go in between 1 and 49. Okay. So I'm going for the 49 up to 49 up to 50 up to 100, something like that you can go. And for each training, each time training, I'm going to find out what will be the accuracy. I'm going to find out accuracy also. Okay. So I'm going to get accuracy 2, I'm going to get accuracy 3, here I'm going to get accuracy 49. Okay. So this type of the things I'm going to get, and I will check that which number of the neighbors k is basically is better. Okay, is the best, that which how many neighbors we are going to take, whether we are going to take 8, whether we are going to take 10. Okay, so which accuracy, which number of the models is giving the best accuracy. Okay, so I'm going to stick with that accuracy. Okay. So let's move ahead and quickly do the things. So what can you do? Just import all the things, and you are going to, again I'm going to take same data set. Okay, and I'm going to find out the input features and the output, and here I'm going to put hyperparameters. That will be what I'm going to find out grid search. Okay, what grid search means? You have divided, you have some values in grid form. Okay, like actually in row and columns. Okay, but here I'm going to take only row. Okay, and it will, that row or the array will contain value from 1 to 49. Okay, so what it will do, you can make like not only one hyperparameter, you may take 2 parameters, you may take 3 parameters. So it will be like how much? It will be in row and column format. Okay, if you are having let's say that next multiple hyperparameters we have here. Okay, I will show you. Okay, so these things will be in the grid format. Okay, so here we have only one hyperparameter is going to take into that. Okay, this grid search cross validation. Okay, it's very important for the hyperparameter tuning. Okay, so what it will take? It will take this algorithm or this model, that is k neighbor classifier that we have imported here. Okay, from the neighbors. Now this model will be trained on what? This model will be trained on your Uh, okay, so whatever the things are there, first the model will be trained for the neighbor is equal to 1. Then it will be trained for the neighbor is equal to 2, neighbor is equal to 3. Like you will get how many 49 models you will get in this range. It will go from 1 to 49. Okay, so you'll get 49 models. Each model is trained with different neighbors. Okay, different neighbor values. Okay, now you will get 49 accuracies for the models. Okay, now you are going to take which neighbor, like which neighbor values, number of the neighbors values gives the best accuracy. Okay, let's train this one. Now you can find this is 8. So when your model was trained using k is equal to 8, using your number of neighbors is equal to 8, that model was best performing model. Okay, so that will be your best score. So you can use now further you can use, okay, for this particular data set, for this particular k neighbors classifier, my model is working best for the 8 neighbors algorithm. Okay, so by one you can go and find like for one time you pass the parameter number of the neighbors is equal to 1, then next time you pass number of neighbors is equal to 2, next time you pass, okay, like these. Okay, you go and like this you can go, but in that case what, every time you have to go and every time you have to find out what is the accuracy, what is the accuracy, what is the accuracy. Okay, now you can find out the best accuracy and respective number of the neighbors. You can go like this. But if you are using this grid search, so it will give you in one step, you will get all these things. Okay. So this will be k-nearest neighbor. Now you are going to take grid search, cross validation, same way that already we have done cross validation. So it will take your model, it will take the grid will give you these things. Grid will give you the variety of the values 1, 2, 3, 4, 5, 6, 7, 8, and that variety of values is what, nothing but this is the neighbors. Okay, so this is the number of the neighbors, and neighbors, it will it should be same parameter, exactly whatever the parameter name you have here, n underscore neighbors, that should be here. Okay, so this should be there, and this will be the range from 1 to 50. And again you are going to find out fit. When you did fit, you are going for the best parameter, and this kn underscore this model is nothing but you are going to find out parameters, you are going to find out best score. Okay, so it will give you the best parameter whatever you have here. Okay, if you have multiple parameters here, in the next we will discuss about, so you will get the multiple best parameters. Okay, for each parameter what is the best value. So let's run this one, you will get 26. Okay, so we already have. So for the n is equal to, or the number of the neighbors is equal to 8, the best accuracy is 75%. Okay, now let's move to the decision tree, and we are going to take in decision tree. You can find decision tree classifier. You can find out here that what different types of the parameters you should have to pass. Okay, so whatever the parameter you are passing to these classifiers or these algorithms or the models, okay, these the values you are passing, so that's why these parameters will be called as what, hyperparameters. So whether you are going to take Gini coefficient on the basis of Gini, or you are going to take entropy. Okay, so this will be your one hyperparameter, and splitter is best. Max depth you are going to take. Okay, whether whatever the max depth is, so 0 or 5 or 9 or something, like none is by default if you are not going anything. So it will go up to what, it will go up to the end and the like leaf node. Okay, we have discussed in that. So minimum sample required, you have to pass all these things. There you can pass different things. Okay, so let's take like 1, 2, 3, 4, 4 hyperparameters, and make sure these values, like say criterion is there, So this should be exactly as it is. Okay, max underscore depth, min samples split, and min samples leaf. All these things. Okay, so we are going to pass some values, criterion for the Guinean entropy, max for the none 5 0. It is for the 2 5 10. You can give more values. Okay, not only 2 5 10 15. You can give 1 2 3 4 5 6 7 19 15. Okay, so this will create a grid, okay? Row and column wise grid it will create. And what it will take for, it will take first Guinea and it will go for the none and the min sample is split to and one. It will go for the none to and see, okay, different like different combinations it will take, and how many one, two here. So how many combinations it will have. Let's check. For this particular, you have two. Okay, for this thing, one, two, three. You have three. For this, you have three. For this, you have three. So you can multiply, and how much it will be? 27 into 2, how much? Okay, 54. So you will get 54 combinations, means 54 times it will make what? 54 models you will get. Okay, with different combinations of the criterion and max depth. Okay, so out of those 56 or the 54, how much we have calculated, which the combination is the best, which combination is giving the best accuracy, that will be your best criterion value, best max value, best max depth value, best mean sample split, and best mean sample leaf. Okay, all these things. So you will get, okay. So we have divided grid and we have divided your decision tree classifier as decision tree classifier random, and you are going to work on what? Grid search. So you have to take grid search like earlier we have taken. You are going to put the model and you are going to put your grid. So it will take all these things here. Okay, so out of this, it will take one combination, like first, let's say first combination is Guinea none 2 1. Okay, it will give these parameters to this decision tree classifier, and it will fit the model and find the accuracy. Okay, next it will take the next combination and do all combinations. Okay, all permutation and combination it will take, and it will give you what will be the best combination for the this one. Okay, so best combination is what? Guinea criteria should be Guinea. Okay, and max depth is 5. That is good. And your min sample leaf is 3, and min sample split is 10. Okay, so these are the, out of these, whatever we have passed, the best criteria, is Guinea. Max depth you are taking 5, and this you are going to take I think min leaf. Okay, max depth is 5, min sample leaves. Okay, min sample is this one, gives the next one. Okay, 3, and min samples is split as 10. Okay, so these will be your best hyperparameters, and accuracy for these best hyperparameters is 82%, 82.9%. I hope this makes sense. So up to this, we have done all these things, and we are going to work on. Okay, next, when you did hyperparameter, okay, when you find that, let's say my criteria is this, my max depth is this, my min sample leaf is this, my min sample split is what? 10. Okay, then you are going to say that accuracy is the best one. So for this, but these particular hyperparameters, you are going to train and you are going to find out the actual model. Okay, here the main thing comes. Okay, so let little bit me explain. Okay, so you have your model and you trained with different hyperparameters. You find the best parameters, okay, with the hyperparameter tuning. Okay, grid search and all these things you have taken. Okay, hyper best parameters. Okay, best parameter you find. Now you are going to train the model with these best parameters. You train the model. Now you are going to save the model. Okay. Training is done. Now you are going to save the model. Okay. How you are going to save the model? Means whatever the saving model means what? You are going to, if you are going for the decision tree, if you are going for the different regression or something like that, so whatever the learned pattern is in the decision tree, what was the structure of the decision tree, okay, that you are going to save basically. Like say that root knows what this, okay, then you divide it into two different, you are going to find out yes, no, you are going to divide into this, okay. So this tree structure you are going to save in your model along with the values of the best parameters, okay. So when you are going to use, you are going to, for the prediction, you can use these tree structure for the classification next time, okay. So this will be one thing that you can save as a pickle, okay. So you are going to import pickle and whatever the best parameters, best values of the hyperparameters you have taken, that you are going to pass and you are going to train, okay. Fit means you are going to train, and now you are going to save your model as what, this is file name, just file name it will be, and now you are going to means whatever you can do here, the model, okay, pickle.dump model, and it will basically open this file and with write, okay. So what it will do, it will save the model, this model, whatever the model is trained. After training the model, whatever the structure or the pattern you get in the model, that this will be saved as pkl, as pkl file, okay. Next time, whatever the things, this whatever you have done, exploratory data analysis, pre-processing, and these validation and train test split, all these things, training and testing, prediction, all the things you have done. But finally, you are going to take only this model.pkl file. Okay. When you trained all the things, now you have to save this model.pkl file, and this file is going to use for the prediction for the new work. So now what you have done now, okay, any doubt is there? So if you have no doubt, so what you will get, basically what you are going to do, you are going to save that model. I will show that how it will look, okay. Actually you are not going to open with our like editors, there are different editors. So these values you are not going to find out the what values are inside this model.pkl is, okay. So just run, okay, you are going to train, you are going to do, and you are going to do this thing dump. So it will be saved, model will be saved here, okay, in the content. So this model.pkl is saved, but the values you are not going to get, okay. You are not going to get the what different values it has stored inside it, okay. SQLR, class, classifier, criterion, SGNI, splitter, best, all these things you can get. Little bit you can get, but all other values they are not readable. Okay. Now, once you have, you can now what you can do, you can go and you can download this model. Okay. So this will be very useful. Next time when we are going to use this model, this will be very helpful. Okay, now you can go and you can go here and that you can open, but you will not be able to open this. Okay, you will not be able to open anytime. Notepad, can we go for the notepad? Can you open? Oh, no, you'll open like this. Okay, some values you will get max depth, sample, split, all these things, but most of the data you will not be able to find, okay, that what exactly inside the model is, okay. Now you have to load, okay. Now you are going to, again you are going to use this picker, you are going to load and again give the file name, whatever file name is, just give file name and you are going to open, okay. So basically Here you have to pass the exact value. Here you are not going to do like this. So in that, let me put here that file name is what. So you have to find the proper file name. If you are working in locally, if you are working, okay, so that's fine. You are directly you write whatever the file name was exactly, you will get at the same location. Okay, after downloading, no, it will you need not to download if you are working in your local machine. Okay, your local laptop you are working, so in the same directory at same location where you have data, where you have this file, okay, zip for notebook file, this model.pkl will be saved. Okay, and already we have written here file name. So just you have to give this file name and you are going to do, and now you are going to predict. Okay, you can use to predict. This model you are going to use to predict what is the problem. Model load and use the loaded model to make prediction. Okay, model dot invalid load key. What is this error? Why I'm getting like this error? Can we do something like that? This one model. Okay, this should work. Locally it was working. Yeah, so maybe with that we have here in this maybe load issue is there. Locally it was working, and most of the time you will work. Okay, so let me explain that whether this AI can explain or not. What it says. Okay, I mean there invalid key. Again, you will get. Okay, let me do something like that. Okay, uh, whatever. So how can I do it? Okay, just I'm going to do this thing, and I'm going to do what it says. Okay, you were on there. Okay, so what we can do, we can directly pass here the sorry, oh, it is working. You can do like this. Okay, invalid. Oh, sorry. So what can we do? Where is my actual? Okay, here is my actual. So what can I do? Let me just copy this one and copy and make me here some. Okay, let's just maybe that what happening is not copying because it is how can I okay just accept so that it will make something like that. Okay, so what we are doing here, just file name, I'm going to copy the path of this file and I'm going to pass here within these two things. Okay, why read? Okay, I'm going to read only and I'm going to do this. Okay, and invalid. I have to check that why it's not working. Probably invalid load key and these things. Locally it was working. Either is there any other thing for the reads we can do like this? No. Okay, so what can we do? Okay, let's. So actually, you have to save and okay, so we are not going to predict. So tomorrow I will show it properly locally. Okay, that how it is working, and that is basically we are going to use this model. Okay, actually this model, whatever we are going to save the model, whatever the model we have saved, actually I am going to use that model to predict. Okay, so what we will do tomorrow, we are going to do these things. So tomorrow's session will be like the important session. So we have saved model, So that is, let's say, model dot EKL. This will be my model, okay? And we are going to call this model, okay? And I will give some input, okay? And I will predict some output, okay? I'm going to predict the output, okay? So what it will do, and this model I'm going, these inputs I'm going to take from the users, okay? So from the users, so I will create a user interface. Let's say that this will be my user interface, and the first value I'm going to find here, the second value, the third value, the fourth value for the fourth feature, okay? So this, you are going to, let's say that, enter what is this, what is age 49, what is the skin thickness, let's say 3.33, okay, something like that. And you are going to have your like predict, okay? So it is going to predict whether, when you click on this, it will give you whether it is diabetic or not diabetic, okay? So it is going to predict the class of the disease, okay? So it will be proper, okay? So we are going to work locally, and we are going to use most probably the Flask app to, like, from the server, and this to make a server, okay? So we are going to put this model on our server, and we are going to use this HTML form, okay, to access the model, and we are going to pass this data to the model, and then our server will return some, whether it is 0 or 1, okay? So on the basis of this thing, we are going to completely deploy our model, okay? So tomorrow we are going to work on the model deployment, okay? Model deployment, basically. So complete all the things. So we have done all the things up to this model. We get our model locally, and now we are going to use use that model to predict or to classify, something like that, and you will get all the things for how I'm going to take the user input, and how I'm going to run the server, and how I'm going to get the response from the server, and uh, output the server output the response on the user interface, okay? That will be my HTML form. So hope up to this you have got the a lot of things like supervised, unsupervised, how we are going to train model, how what different types of the machine learning models are. Now finally we have saved our model, and in the next session we are going to deploy this model, okay? And we are going to actually predict that it will make sense that how it works, basically, okay? So please let me know if anyone has any doubt, whether it's time to like close the session, conclude the session. So tomorrow, I think we have 1 hour this session, machine learning session, and you may have, like, I think ma'am will confirm, you may have 1 hour, the last 1 hour for the some quiz type things you will have, quiz or the exercises you will have. So please let me know if anyone has any doubt, and so we can discuss the doubts. If not, we can go for the conclusion of the session.
So you're done with the session?
Sorry?
You're done with the session, sir?
Yes.
Okay.
Completed,
Then.
yes.
Thank you, sir.
Yeah.
So dear students, just one announcement. As sir mentioned that tomorrow definitely we're going to have the test in the last 1 hour. Okay, so please be prepared on whatever we covered in the last 14 days. And tomorrow we'll have a 1 hour of session, 1 hour of test. For today, I already shared the attendance link into the chat box. Please mark your attendance and share your valuable feedback about the session. About the certification of this program, we'll explain in tomorrow's session. Okay. Okay, sir. So can we wind up for the day?
Yes, we can wind up. Yeah, we
Okay.
can
Thank
conclude
you.
this.
Thank you, sir.
Yeah,
Thank you,
go ahead.
student. We'll see you tomorrow. Bye bye.